Hello everyone, Mr. Fawcett here, and we are back with another Algebra 1 lesson. Today we're going to talk about our last strategy for how to solve a quadratic equation. Previously we've looked at the square root method. In our most recent video we talked about the zero product property, so factoring and then setting all the factors equal to 0. Today we're going to talk about the quadratic formula. So to start, we're actually going to look at the one here on the right, the one that says x squared minus 8x plus 14 is equal to 0. And we're going to try to solve this using the zero product property. So you're going to want to try to factor and then set your factors equal to 0 and solve. And maybe you'll be able to, maybe you won't, but pause the video and take some time to try to do that. Okay, so if I'm trying to factor, I can just use the factor sum chart because this a coefficient is just 1. So I'm looking for factors of 14 that sum to -8. So I can try 7 and 2. Although these factors are going to have to be negative, right, if I need to get -8. So let's do -7, -2. That adds to -9. We can do -1, -14. That sums to -15. Can we think of any other factors? Well, it turns out there are none. Right? These are the only two negative sets of factors of 14. So we're kind of stuck. Factoring is not actually going to work here. And we need another method, right? Because we can't use the square root method because we have this x term. So the square root method's not going to work. Factoring doesn't work. Well, this is where the quadratic formula comes in. Here it is right here. We're not going to prove why this works. That's something for a higher level math class. So we are just going to memorize it. And the more you use it, the easier it will become to memorize. I know it looks very complicated when you first look at this, but once we break it down, hopefully it becomes a bit more straightforward. One thing's important. Before you use a quadratic formula, you must put your equation in standard form. So the standard form of a quadratic, ax squared plus bx plus c equals 0. If you may need to rearrange some terms so it looks like this. For instance, if you had 4x squared is equal to 2x minus 10, well, this is not in standard form, so you're going to have to do a couple of inverse operations, right? You're going to have to subtract 2x from both sides. And actually, you can move the 4x squared to the other side, but I like having my a coefficient positive. So here I would get 4x squared minus 2x is equal to -10. We can move the -10 over by adding. So I get 4x squared minus 2x plus 10, is equal to 0. And now I would be ready to employ the quadratic formula. So once your equation is in standard form, we're going to use this formula. This formula will give you the values of x that are solutions to the equation. And you'll notice that because of this plus minus sign here, that will allow you to sometimes get the two solutions, which we found when we'd use the zero product property and the square root method, because we know a quadratic equation can have 0, 1, or 2 solutions. Let's do an example so you see this formula in action, and then you'll have some time to practice on your own. Let me still leave this here, but we'll have enough space. Okay, so the first thing you may want to do, especially when you're first starting out using this formula, is label what your a, b, and c are. So here, my a is 7, my b is 3, and my c is not just 16, it includes the sign. So in this case, it's -16. So now I'm going to substitute all of those numbers into this formula, and then we're going to have to simplify. So I'm going to get x is equal to -b, so it's the opposite of b, so in this case -3, plus or minus the square root of b squared, so 3 squared, minus 4 times a, which is 7, times c, which is negative 16, all over 2 times 7. So I haven't simplified. All I've done is substitute so far. Now we need to simplify. You're not going to want to punch all of this into your calculator. You're going to want to simplify it in pieces, and then maybe at the end you may punch it into your calculator if need be. Let's start with what's underneath the radical. So maybe a different color so you guys can tell each step apart a little bit easier. Let's do orange. So I have x is equal to negative 3 plus or minus. Okay, inside the radical, I can do 3 squared. That's 9. 4 times 7 times negative 16. That's going to give us negative 448. Now, it's very important you keep track of your signs here, right? I'm subtracting negative 448. In my denominator, I have 2 times 7, which is 14. Let's come up here. That's going to give me x is equal to negative 3. Let's not forget that plus or minus sign. 9 minus negative 448 is like adding, right? So it's actually going to be 9 plus 448. That gives us 457 all over 14. Now, sometimes what's underneath the radical will be a perfect square, right? So you could test it on your calculator. You can do the square root of 457. But that turns out to be approximately 21.378. So what I'm going to do here is I've got x is equal to negative 3 plus or minus 21.378. Now, I didn't tell you what decimal place to round to, so I'm just going to 3. When it tells you, though, then you may need to go to 2 or 1 or 4, etc., based on the directions. Once I get to this point right here, okay, there's no more simplifying I need to do except this last step, right? So I'm actually going to come up here. We're running out of space. You guys have plenty of room on your paper, though. So I'm going to have 2 answers here. I'm going to have negative 3 plus 21.378 divided by 14. That's going to be equal to something. And I'm also going to have the negative. I'm going to be subtracting 21.378. So I'm going to have negative 3 minus 21.378 all over 14. So we need to simplify both of those, and those will be our 2 solutions to this equation. So let's go ahead and do the green. I've got negative 3 plus 21.378 divided by 14. That gives me approximately 1.313. Oops. Oops, I need to change my color. I'm actually just going to go to 2 decimal places here. So 1.31. Generally, if you round in the middle of your problem, right? So we rounded to 3 decimal places in the middle of our problem, which means I'm going to round to 1 less at the end. So let's say I needed to round to 2 at the end of this problem, then I would round to 1 more, 3 decimal places, if I was rounding in the middle. It's just going to make your answer a little bit more precise. For blue, if I subtract that's going to give me negative 1. Oops. You know what? Let's just do this down here. This is approximately equal to, I don't forget my signs, negative 1.74. Let's make sure we have approximately equal to up here. It's not exactly, but approximate. So this is your first foray into the quadratic formula. It looks a little complicated, a lot of stuff to keep track of, and it is. But the more you do it, the easier it will become. One thing to note is that you do not have to round right here. We could eliminate this entire step, right? And we could just punch this into our calculator twice. We could just keep it as the square root. So it's kind of up to you. You can either keep the square root when you punch it into your calculator, or you can make it a decimal before you punch it into your calculator. It's not going to make too much of a difference. Your answer will be slightly more precise if you punch in what I've circled in orange than if you punch in what I circled in pink. Because in the pink, we've already rounded. In the orange, we've left it as an exact square root. Let's go ahead and do another one or two together. Make sure we get the hang of this. Let me write the quadratic formula here off to the side, just so we remember. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. There's actually a catchy song. I think it's set to Pop Goes the Weasel. But if you want to YouTube the quadratic formula song to Pop Goes the Weasel, it's pretty catchy and it might help you remember the formula a little bit easier. No, I'm not going to sing it for you on video. So I'm going to label my A, B, and C. But maybe if you guys remind me in class, I'll play this on for you, and in case you haven't looked or you weren't able to find it. Okay, so I'm going to start substituting. I get x is equal to negative b, so negative 4, almost wrote negative b, negative 4 plus or minus the square root of b squared, so 4 squared, minus 4 times a, which is 6, times c, which is 10. All over 2 times a, which is 6. Let's start simplifying. I'm going to get x is equal to negative 4 plus or minus the square root of 16 minus 4 times 6 times 10. That's 240 all over 12. Let's jump up here. Simplify again. 16 minus 240 is negative 224 all over 12. Now, normally we could just jump right to our calculator here. We could do one answer where we use the plus sign, one answer where we use the minus sign. And go ahead, you can actually punch that into your calculator. Let me split this up and just show you what I'm talking about. All right, so we're going to have x is equal to negative 4 plus the square root of negative 224 all over 12. And we're going to have x is equal to negative 4 minus the square root of negative 224 all over 12. So punch this into your calculator and see what you get. Pause the video. Okay, so you're probably going to get an error, or your calculator may say non-real answer. And maybe you caught on to this before you even punched it into your calculator, but we have a negative number underneath the square root sign. Well, we don't know how to take the square root of a negative number, right? Remember I told you that you can take the square root of a negative number, but the answer is going to be a number that you've never seen before, we've never worked with. It's going to be called an imaginary or complex number. For now, though, whenever we see a negative number under the radical, we can automatically say no solution. And that's what this equation has. There are no solutions to this equation. And that's what's going to happen when you get a negative number underneath the radical. So sometimes it works out and you're able to find one or two solutions. Other times, you may get no solutions. So you just want to be prepared for the different scenarios that you may encounter. Let's do another one. we'll do number 1. And that'll do it for this video. Number 1, our A is -4. Our B is -11. And our C is 9. So when I start to, and let me just cross this out. That'll let us know we're not actually going to do that one. So I'm going to get x is equal to -b, so negative or minus -11. All right, remember the quadratic formula, -b plus or minus the square root of b squared minus 4ac all over 2a. So I have minus -11 plus or minus the square root of b squared, so -11 squared, minus 4 times a, which is -4, times c, which is 9, all over 2 times -4. All right, we got quite a bit of simplifying here to do. I'm going to get x is equal to positive 11. Right, 2 negatives are going to make a positive, plus or minus the square root of, now -11 squared is going to be positive 121. Yeah, if you square a negative number, you're always going to get a positive number. A lot of students make the mistake and they say -11 squared is equal to -121. And that's because if you punch this into your calculator like this, your calculator is going to tell you it's -121. But that's because you've forgotten the parentheses. If you put the parentheses outside of the negative sign, like they're supposed to be, then the calculator will change this to a positive. But we should know, right, intuitively that if I square a negative number, it's going to become positive. So even if you make the mistake in your calculator, your brain should catch it and be like, maybe I didn't type that in right because I need to get a positive. Again, super common mistake that teachers see when students are working through these problems. All right, then I have 4 times -4 times 9. That's going to give me -144. So I have minus -144. If you wanted to, you could just make that positive here and skip a step, but I'm just going to do one step at a time. Our denominator is going to become -8. Let's do one more step over here. So I'm going to get x is equal to 11 plus or minus the square root of 121 minus -144. Well, that's really like adding. So I get 121 plus 144, and that's going to give me 265 all over -8. Let's give ourselves some more space. And we're actually ready to break it off into 2 solutions. So for one, I'm going to get x is equal to 11 plus the square root of 265 all over -8. And for my other one, I'm going to get x is equal to 11 minus the square root of 265 all over -8. Now you just need to punch both of those into your calculator to figure out what the solutions are. One of those solutions should be x is approximately equal to, and it says round to the nearest thousandth. So that's 3 decimal places. So I'm going to, x is approximately equal to -3.4, it actually becomes 409.8. The 8 is going to bump this 9 up to essentially 10, which bumps this up to a 1. So what this becomes is -3.410. It's one of our solutions. The other one, as I punch this in myself, we get x is approximately equal to 0.6. Same thing happens. We get 6598. That 8 bumps the 9 to a 10, which bumps this 5 to a 6. So we get 0.660. Those would be our two approximate solutions. Now, if you simplified this radical before you punched everything into your calculator, you would want to go to 4 decimal places. For instance, if you did this, if you did x is equal to 11 plus, and then you punched in the square root of 265 to get 16.2788, you would want to go to 4 decimal places. Okay, again, if your final answer is 3, go to 1 more when you're rounding in the middle of the problem. The best is just to punch in this entire thing here and this entire thing here. But if you are going to round in the middle, make sure you go to more decimal places than your final answer needs to be. Okay, I think we have gone long enough in this video. There's plenty of other practice problems for you to work on. There is one scenario that we haven't touched on in the video, and that's where you get just one solution. So we've covered when you get 2, when you get 0. There is going to be an example when you just get one solution, but I think that's a little bit easier to figure out than 0. So we'll stop it there. As always, enjoy the rest of your day, and I absolutely look forward to seeing you for our next video.